Welcome to MFTS 215, Industrial Relations, Safety, and Health. I'm going to talk about Chapter 1, the employee's role in safety. So this book is concerned with the processing industry. Processing industry takes raw materials and turns it into useful goods. So a big emphasis is the chemical industry for this book. So dealing with pipelines filled with dangerous chemicals, tanks, steam, electricity, all kinds of things that can go on in a big manufacturing plant. Although it isn't specific to manufacturing, just about everything in this book can apply to a typical manufacturing plant, whether it be, injection molding plastic or taking, slabs of aluminum and machining them into useful shapes. Two terms that we're going to cover in this first chapter are safety and health. Now, typically they're used interchangeably in normal vernacular, but in this book, we're going to give them specific meanings. So safety is concerned with injury-causing situations. So hazards that result from severe conditions. An example is something like a slip and fall, or an explosion, or mechanical failure. Safety issues typically happen quickly. Health is concerned with disease-causing conditions. These are long exposures to dangerous but less intense hazards. Some chemicals, some gases are going to knock you out really quick. If you walk into a room that's been purged with argon, you'll be on the floor in a couple seconds, maybe a minute if you hold your breath. Some chemicals, like asbestos or lead, take a very long time to take their toll. So it's important that we identify those chemicals that are hazardous, whether it be a really fast hazard, it knocks you out immediately, or a really slow hazard, something like asbestos. In addition to the obvious, chemicals, you don't want to get acid on your face, you don't want to breathe in argon, with no oxygen. There's also light, so things like lasers. It could be something simple like a measurement device, a laser level finder, or a commercial laser used to cut materials. You don't want to go try to repair a laser and accidentally get hit in the eye with it. You can go blind. Sound is another one. Most manufacturing plants have earplugs all over the place, and they tell you to wear them. Now, this is great, but if you choose not to wear them and you lose your hearing, the company is not going to cover your expenses because they provided the hearing protection and told you to wear it. So it's up to the individual person to wear the correct PPE when you're supposed to. That PPE is there to protect you, but it's also there to protect the company. If they provided it, they assume you should be wearing it. Next, let's talk about a more amorphous topic. So this is known as the culture of safety. In this book, safety is defined as an attitude. Everybody is involved in safety, so it's not just a management problem or a shareholder problem. It's everybody at that facility. Whether you're repairing a machine, you run that machine every day, or you're an outside contractor that comes in to install some new equipment. Everybody needs to be on the same page about potential hazards, how to mitigate them, plans for when things go wrong, which is a huge deal. Every company should have a plan for things like spills, fires, gas releases. It's not good enough just for everybody to run out of the building when there's danger. That can lead to even bigger problems if the whole building explodes because nobody knew how to handle the situation. So it's difficult to say what kinds of organizations have good cultures of safety. We're typically going to say companies that have few accidents have an excellent culture of safety. But some companies have less risky endeavors. So I worked for a toothpaste factory on the night shift for a while. Not too many terrible things happened at a toothpaste factory. You have giant vats filled with basically soap and a little bit of fluoride. They can't explode, they can't catch fire, It's pretty innocuous material. Now, accidents could happen. You can get run over with a forklift. There are lots of slip and falls, things like that. Soap is slippery. But on the whole, not too risky of an endeavor. An example of what's generally considered a bad culture of safety is the space program. So NASA, after the Apollo program of the 1960s and early 70s, embarked on the space shuttle program. Now, the big difference between the Apollo and the space shuttle program was budget and mission. So the Apollo program had a very simple mission: get to the moon. And the budget was basically whatever they wanted. So it was easier to create safety in that environment when your budget is almost unlimited. You have a very, very clear goal in mind. After the Apollo program, so the late 70s, early 80s, the big problems they had were that the mission was vague. We knew we wanted to keep going to space. Nobody could really explain what the goal was. Was it to go to the moon again, Mars, live in the space station? It eventually became launching and recovering satellites and maybe a space telescope here or there. So that vague mission creates indecision downstream. So it doesn't directly affect safety, but it comes into play with the other thing is that their budget basically got cut every year for decades. They were trying to do more with less, and that's a recipe for disaster. And as everybody knows, Challenger went up in 1985 because of an O-ring issue. It was a mechanical failure, but it could have been prevented with the proper safety inspections and checks, and most importantly, just stopping that shuttle from taking off. Now, you don't have to take my word for it. There's whole books written about it. There's great documentaries on it, but there's competing interests. They wanted to get the shuttle launched on time because they wanted to get the shuttle launched on time so that they could get another shuttle up there to justify their budget. This was getting to be a bad culture of safety. There's always going to be time and economics involved with safety, but with an extremely risky endeavor like spaceflight, they essentially let their budgetary and time constraints take over the safety constraints. An example of a really good record as far as safety is concerned is the naval nuclear program. So there's a lot of nuclear submarines and nuclear aircraft carriers since the 1950s in the United States Navy. There has yet to be a single serious accident with a nuclear reactor at sea in an American ship. Now, there are 2 submarines lost at sea. One of them is kind of a mystery. The other one is most likely a mechanical failure not related to the nuclear reactor. So these people, the Naval Nuclear Program, have a very large budget and a very clear mission of what they're supposed to do. They're supposed to create safe, reliable reactors for the Navy. They have very long design lead time, so it takes like 20 years to design a submarine. They're not pressured for time. They have a clear mission. They have a great culture of safety that is maybe a result of all of those things. The next item is the idea of a risk-free environment. So there is no such thing as a risk-free environment. You could walk outside your front door and get hit in the head with a meteorite. On the other hand, if you're going to leave your driveway, you can buckle your seatbelt on the off chance somebody is, speeding through your neighborhood. It's a much more likely thing to happen. So let's talk about what risk is. Risk is a combination of the impact, so how bad something is. Is it tripping over a curb and hitting your head, or is it tripping over a fence and falling off a cliff, right? How bad is the impact of whatever's about to happen? The other part is the probability. So how likely is the thing to happen? So we take probability the impact, and then even economics goes in there too. Now, we can't protect every single person from meteorites. It is a possibility that a meteorite can just fly through your ceiling and hit you, but we can't put titanium shielding in the top of every building because it's economically not feasible. So we can't ever have a fully risk-free environment. But what we try to do is map out the probability and the impact, figure out what the risk is going to be. So that would look something like this chart I can show right here. So in this chart, I've got probability on the vertical axis and impact on the horizontal axis. Probability is how likely is to happen. So at the bottom of the chart is a 0% chance. The top of the chart is 100% chance. Impact goes the same way. On the left-hand side of the chart, 0 impact would mean nothing bad happened, right? You tripped and fell on a patch of soft grass. On the right-hand side of the chart, you tripped and fell out of an airplane, right? So if something has a high impact but a low probability, it's a medium risk. If it's a low impact, low probability, we have a low risk. High probability, low impact, it would be a medium risk, something like a slip and fall. It's typically not too dangerous, but you don't want to be slipping and falling 3 times every day at work. And then, of course, the high impact, high probability events. So these you kind of got to go out of your way to find, because there are usually safety guardrails anywhere you are working. So now we can discuss the employee's role in safety. As we talked about before, safety is not just a management issue. Every employee should have an active part in safety. Every employee should be able to stop work, right? So if you see something dangerous about to happen, every single person in a plant should have the power to say stop, hit the emergency power button, and make everything stop, from management down to, whatever job position. Even if a custodian sees something dangerous happen, you go ahead and hit that emergency stop just in case. So employees should take an active role in safety. There's something called the SH&E department in most companies, the safety, health, and environment. These people typically write procedures. So as we discussed before, plans for when things happen. They aren't hall monitors. They're going to walk around and correct every little safety imperfection. They're there to make sure the plans are in place, and maybe occasionally, depending on the company, do spot checks to make sure everybody's following the rules. As we discussed before, it's not just, say you're running a machine, it's not just you who should know what's dangerous about that machine. Anybody that goes near it, anybody that might come in to repair it, so things like outside contractors, you have some electricians come in, they should be aware of whatever safety measures your company takes. You shouldn't be the only one walking around a facility without a hard hat on. If everybody else is wearing a hard hat, same thing with safety glasses. If one person is wearing them, basically everybody should be wearing them. The employee skills are technical expertise, regulatory knowledge, communication skills, computer literacy, interpersonal skills, problem solving, the ability to train, and then the quality and continuous improvement. I'll just touch on some of these employee skills. Some of them are a little bit vague, but very important. So communication skills and interpersonal skills really do matter and have been at the heart of some industrial accidents before. So say somebody saw something happen and they didn't know how to accurately communicate it in a written manner. So maybe they weren't computer literate and they couldn't get the report, the details they needed to. The next shift comes in, can't really understand it, and then something blows up, right? Interpersonal skills really do matter. When we talk about the Chernobyl disaster, If you saw the HBO miniseries, they really captured it well. But they had real problems with people in the control room not trusting each other, not getting along, not being able to say no to their superiors when they knew something was wrong technically. Regulatory knowledge, well, everybody isn't expected to know every single regulation, but depending on your industry, you should know the basics, right? You shouldn't throw lead acid batteries into a garbage disposal. If you have an oil spill, you should contain it and figure out what to do with it according to hopefully whatever plan your SH&E department came up with. You should at least know what you don't know. So if you have a chemical spill, you shouldn't sweep it under the rug, figuratively or literally. You should find out exactly what you should do just by knowing that chemicals are bad and you should treat them with care. So that concludes Chapter 1 of the textbook.